Hi class, so I'm going to be working through Unit 1.5 and the notes handout that you guys should have already. This is so if you need to go back and watch anything again, please use this as a resource. The nice thing here is that you can pause and go back and rewatch it as much as you need, but then if you still have questions, it's super important that we get this mastered, so please ask me. All right. So, going over quantum numbers. And again, quantum numbers, these are just kind of a way of coordinates of telling us where our electrons are in our orbitals. Remembering that we have principal energy levels, which break into sublevels, which each sublevel has their own set of orbitals, and each orbital holds 2 electrons. So, it's a kind of a way using 4 numbers to tell us where these electrons are. So we'll start off by defining the quantum numbers. N has to do with the principal energy level. L is associated with sublevels. M has to deal with the orbital. And S has to do with the electron's spin. So the biggest thing I want you guys to get out of this table below is that the N is just whatever principal energy level you are. So for example, if you have something like 1s2, 2s2, these numbers out in front, the 1 or the 2, those are your principal energy levels. So you would just put n equals 1 or n equals 2, depending on what electron you're talking about. The next part we have is sublevel L. It's just as simple as once you determine n, it is just n minus 1. Now, orbital M, or quantum number M that has to deal with orbitals. The easiest thing I found is referring to this chart. And so we know that S sublevels only can have 1 orbital. So they're only going to have one possible option for M's, and that's M equals 0. Then, as you move on, P sublevels have 3 orbitals. So you can be either -1, 0, or 1, depending on what orbital box you're in. If you're in the first box, -1, middle, 0, and then 1 if you're on the rightmost box. Then as you add orbitals, so D now is 5, you just expand the negative and the positive integer by 1. So the leftmost is -2, then -1, 0, 1, 2, and F is -3 through +3. So we'll practice this here. I have a question here asking, what are the quantum numbers for an up electron in the second orbital of the P sublevel third energy level? Whew, that is a lot of information, so we kind of want to pull things out one at a time. Well, we know we're working with the third energy level. If we're working with that third energy level, we automatically know n is equal to 3, which then gives us our L, because L is equal to n minus 1, which would be 3 minus 1, which is 2. So now we have to figure out M and S. So we are looking at an up electron. So for electron spin, if it's up, it's +1/2. I'm going to put this under that table here. And then if it's -1/2, it is down. So that tells us that our S is equal to +1/2. And lastly, we have to figure out the orbital. So it says that we are on a P sublevel, and we're in the second orbital. So if we look at, change colors here, if we're looking at a P sublevel, that would be this guy. And if we're in the second orbital, this is the first, this is the second, that means M is equal to 0. So how these quantum numbers are typically written are n, L, M, S. So we will write it as 3, 2, 0, +1/2. And that would be our answer. So go ahead and pause here if you want to try the next one. If we were to do this, now we have a down electron in the 5th orbital of the 4d sublevel. So if we're given a sublevel 4d, 4 is our principal energy level, which means that is our N. N equals principal energy level, which is equal to 4 in our case. L is equal to N minus 1, which is equal to 4 minus 1, which is 3. Now, we're in the 5th orbital of a 4d sublevel. So if we think about d sublevel, we will have 5 boxes. Our electron we're looking at is going to be in this box. So if we remember the numbering, it goes from -2, -1, 0, 1, 2. That tells us our M is equal to 2. And then down electron, S is equal to -1/2. So if we write it in the parenthesis form, we have 4, 3, 2, -1/2. Okay. So now I'm going to fix this typo. This 3D5 should really be a 3D7. So I will highlight what I just changed there. Okay. So now we're going to write the sublevels above the orbital boxes and fill in the orbital box diagram. So we are given the electron configuration, which saves us some time, but then labeling the sublevels, we have 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. So your orbitals might have looked a little different, but this is how I would have laid them out, is because we always fill 4s before 3d. And now if we're putting in electrons, we have 1s, 2, 2s, 2, 2p, 6, 3s, 2, 3p, 6, 4s, 2, and 3d, 7. So you fill up first, and each box gets 1. So we have 5 out of the 7, so we need to put 1, 2 more in there. So this is the final electron orbital box notation. So let's figure out some quantum numbers. Now, I don't have my sheet of exactly which ones we filled out, so maybe I'll do different ones for practice. So I will highlight 3 electrons, and if you want to practice writing quantum numbers, then that would be awesome. Otherwise, the ones in your note handout are going to be different so these will be different from the ones that we did in class. So first electron we'll do. The second one to practice will be this guy here. And then we'll do this one. Okay, so go ahead and pause and try these. All right, so if I'm writing the first one, remembering we are looking for our N, L, M, and S. So N, what is the principal energy level? In our case, N is just the number in front of our sublevel. So 2, N is equal to 2. Next, we have L. L is just N minus 1, so 2 minus 1 is 1. Then we have our M. M is what orbital. So if we're looking at this P, 2p sublevel here, we have 3 orbitals which are associated with M numbers of -1, 0, and 1. And so our highlighted electron is in the -1 orbital. And then what spin is it? It is up spin, so we get +1/2. Okay, moving on to the next one. So, what is our N? you should have gotten 3. Then we get 2 for n minus 1. That's our L. And then looking at the fact that we have an S sublevel, there only can be 0. So m is equal to 0, and then it is spin down. So we get negative 1/2. All right, and then the last electron here. Again, our n is equal to 3. Then we have 2, because 3 minus 1 is equal to 2. And then we have our m, which we have to figure out. So for D sublevels, it goes from -2, -1, 0, 1, 2. So here we have the -1 orbital. And then the spin. As it's up, that means it's positive 1/2. So these are the answers you should have gotten. Now I had you guys define ground state, excited state, and light in terms of electrons on your own. What you should have gotten is ground state is going to be when an electron occupies the lowest energy level. Excited state is when they absorb energy and rise energy levels. And last but not least, light. That is when the absorbed energy is emitted as electron falls back down. And so that energy is emitted as photons, which are just particles of light. So key here being that there may be many possible configurations for excited state, but the total number of electrons cannot change. So the electrons can move around in sublevels and orbitals, but the total number cannot change. Okay. We got through, I think, just the first box here, but going through it again, we'll add the electrons up. So our shell configurations here that are given, these may not be what is a normal shell configuration for each of these elements. That's the kind of the point, because if they're not the same, that means that that element is excited. This configuration means excited if it does not match what you come up with. So here, remembering that shell configuration is energy in the first, then the second, then the third and fourth energy levels. So if we add up all those electrons, add up all the numbers, it'll give us, point to us to the atomic number, which we can then figure out the element. So you guys should have gotten 21, 11, 14, and 17, 18, 19, 27. So here are the elements. Working my brain, trying to remember. 14 would be, I can't, hold on one moment here. We'll do it like this. Ah, silicone, that's what it is. Okay. All right, so what is the shell configuration then? So even just having the electrons, I can figure out the electron configuration, remembering the fill order. And so again, this will start to be a pattern. You'll be able to just spit it out and repeat it, because every element fills the same in the same order. So starting off, we have 1s2, 2s2, 2p6, 3s2, 3p6. So let's stop and see how many electrons did I use. 4, 10, we're at 18, so I have 3 more. So then I have 4s2, 3d1 as my configuration. So now I want to count up how many are in each energy level for shell. So in the first energy level, I only have 2. So my first number I write, 2. Second energy level, I have 2 plus 6, which is equal to 8. And then third energy level, I have 2 plus 6 plus 1 from this 3D over there, which is equal to 9. And then I have, from my 4, just 2. Does 2, 8, 9, 2 match 2, 8, 8, 3? No. So this must mean it's in excited state. Alright, let's do the next one. So, we're going to practice writing all this. I could practice writing all of this again, but remember, this is the same way we fill for everything. So if I have 11 electrons to go through, 1s2 is 2, 2s2, we're at 4, 2p6, we are at 10, so I only need one more. So I can just change this to 3p, oops, sorry, not 3p, 3s1. And now we have sodiums. So again, if we're adding up for our shell, in the first energy level we have 2, the second we have 8, and the last we have 1 for our third energy level there. This is a better reference. Okay, does that match what was given to us? No. So again, must be in excited state. Let's do silicone. I'm going to start over from the beginning on this again. So fill the same way. 1s2, 2s2, 2p6, we are at 10. 3s2, we are at 12. And then 3p2 for 14. So writing our shell configuration, for the first energy level we have 2 electrons, for the second 8, and for the third we have 4. Does that match? No. Excited. Alright, and then lastly we will do cobalt. So here we have 1s2, 2s2, 2p6, 3s2, I'm going to carry on, 3p6, 4s2, 3d7. That should be, let's count that up, 10, 11, 12, 18, 19, 20, 27. Okay, so adding up for our shell, we have 2 in the first, 8 in the second. Again, this becomes a pattern if you're filling past n equals 1, n equals 2. And then for the third energy level, we have 1, 2 plus 6 is 8 plus 7 is 15. And then 2 in the fourth energy level. Does that match? This one does. So cobalt must be at ground state. Now this is where I left off in lecture. And so I'm hoping that you guys tried to fill this table out on your own. So if you did not, I would like you to do that right now. Okay, so hopefully you tried. We are going to add up the electrons again. So we have 3, we have 8, then we have 5 and 9. So 3 would be lithium, 8 is, gosh, my brain, pull this up again, 8 is oxygen, 5 is boron, and 9 is fluorine. So we've got oxygen, boron, and fluorine. So again, we know this because the number of electrons is equal to the number of protons, which is the same thing as the atomic number. So What's the configuration for this? Again, this is given, so we don't want to just copy this. We want to try and fill it with the normal filling order. So if I have 3 electrons, I would start with 1s2, and then I have 2s1. Does it match? Yes. So it must be at ground. Okay, now we have 8. So how I'd fill is 1s2, 2s2, 2p4. Is that what this is? No. So we must have been given an excited state configuration. 5, 1s2, 2s2, 2p1. That is not what we have. So excited. And then for fluorine, 1s2, 2s2, 2p5. Yep, that matches. So we are at ground. And I just wanted to give you guys a couple definitions here. So occupied would be just having an electron, and this can be for in your principal energy level, sublevel, orbital. So if there's at least one in there, it's occupied. It's full. This depends on what it is. So maximum number of electrons in location. Because remember, an orbital only can hold 2 electrons, so 2, it's full. But the principal energy level, they can hold a ton. So even though some of the orbitals might be full, that doesn't mean a principal energy level is full. So we'll talk about that a little bit here. I brought back a couple tables of like the max number of electrons for the principal energy levels and the sublevels. And so we're going to go through these next couple problems. So now, looking at sodium, I want you guys to write the sublevel configuration. So pause here and then press play when you're ready. So how I'd write the sublevel is 1s2, 2s2, 2p6, 3s1, getting my 11 electrons accounted for and filling in the correct order. So if I were to do the orbital diagram, I have boxes here already labeled, but filling it in, I would fill in the 1s, the 2s, the 2p, and then 3s, just a single lone up arrow. So now the goal here is, can we figure out how many of the principal energy levels, sublevels, orbitals are occupied and which ones are full? So try this on your own. I'll go through the principal energy levels here first, but go ahead and pause again to try it on your own. Okay, so how many are occupied? Well, we have principal energy level 1, 2, we have a couple 2s here, and 3. So there's at least 3 energy levels that have at least 1 electron in it. Now, oops, kind of erased the upper half of that guy there. Okay, so which ones are full? Well, if we think back to our little table here, the first one can hold up to 2, so that is full. Is the second one full? Yes, it has 8 electrons. But the third energy level can hold up to 18, so that one's not full. So we should have only gotten 2 here. Now, let's work with the sublevels. How many are full? Remembering that our table for sublevels is here. Is 1s sublevel full? Oops, sorry. Let's do occupied first. We have a 1s sublevel that's occupied, 2s sublevel, a 2p, and a 3s. So that's 4. Because each sublevel, when it's associated with the principal energy level, like 2s or 2p, those are their own unique sublevel. So we have 4. Now, how many are full? Well, s sublevels can hold 2, so 1s is full, 2s is full. then p orbitals can hold 6, so 2p is full. But 3s only has 1, so that's not full. So only 3 sublevels are full. And then let's do orbitals. Remembering that each orbital can hold 2. It only needs 1 in the orbital to be occupied. So 1, 2, 3, 4, 5, 6 orbitals are occupied. But this 3s is not full, so only 5 are full. Okay. I want you guys to do this for cobalt now on your own. So go ahead and pause and then press play when you're ready. Okay, so writing the sublevel, we have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d7. So if we're filling in the orbital diagram, pay attention that this one's weird because they put the 4s after. So filling it in, 2 electrons in each full orbital. Remembering 3D only has 7, so we fill as 1, 2, 3, 4, 5, going back down. Now we have 7, and then our 4s here. Okay, so how many principal energy levels have at least 1 electron? Well, we have 1. We have the second energy level present. We have the third and the fourth. So we have 4 occupied energy levels. But which ones are full? So that table should tell us that principal energy level 1 only needs 2. So 1 is full. 2 needs 8, and we have 2 plus 6, so those are full. The third needs 18, so if we add them up, or you can also, this is where the shell configuration is handy, remembering that the third number is the third energy level. Do we have 18 electrons here? No, so it's not full. And then the fourth, having 32, well, we only have 2, so that can't be full either. So only 2. Now sublevels. So again, each one of these 1s, 2s, 3s, those are all individual, unique sublevels. So we count each as 1. Which ones are occupied? Well, we have 1, 2, 3, 4, 5, 6, 7 sublevels that at least have 1 electron in it. But looking at what are full, we have 1s that's full, 2s that's full, 2p, 3s, 3p. 3d is not full, but 4s is, so you guys should have gotten 6 here. And then, oops, I erased some of those electrons there. I'm gonna draw that back in. Orbitals. So how many orbitals do we have that are occupied? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And which ones are full? Well, the only ones that don't have 2 electrons in it are these guys here. So 15 minus 3 is 12. And that is the end of Unit 1.5 notes. So if you are still struggling with electron configuration, you definitely are going to want to either read the book or, I'm telling you, YouTube. Not all teachers teach this stuff the same, and if the way I do it doesn't click with you, someone else's video online might help. But of course, I'm always around for questions. Yeah, we'll get through this, guys.